Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics that I am getting request to make a video about the self-compacting concrete mix design using 10mm aggregate. So today I'm going to discuss on these things, how to do a mixed design of self-compacting concrete using 10mm aggregates in step-by-step process. So stay tuned until the end to get the full information about the mixed design of self-compacting concrete using 10mm aggregate. So let's jump into the subjects. So how to do a mixed design. See, there is a lot of process. So I will discuss each and every step by step. So it is my recommendation or request that do not skip any part of this video. Watch this video from start to end. If you skip that, maybe you will missing something. So it is my recommendation to watch this video in full without skipping any part. So first things, in a mix design, what we need to do, what is the grade of concrete. So without knowing the grade of concrete, we cannot do any design. So here it is M50 we will discuss is a higher grade M50 concrete. Now what is M and what is 50, I believe you all know. Still it is the grade of concrete that the minimum cube strength of 150 cube at 28 days should be 50 MPa. So if it is achieved, that means we can say the grade of the concrete is 50. The next part is what is the type of cement. Now in the concrete is a different ingredient is there. Cement is there, aggregate is there, that is coarse aggregate, fine aggregate, then pulverized fuel as GGBS. So whatever we are using, accordingly we need to choose the different types of raw material. So first we need to choose the cement. So here we are considering OPC 53 conforming to IS 269. Why OPC 53? Because it's a grade of concrete is M50. So to achieve that one, the OPC 53 is required. So OPC 33 and 43 we cannot give this strength as much as our M50. So that is why we're using OPC 53 conforming to IS 269 2015. The next part is maximum size of aggregate that today I discussed, that maximum size of aggregate will be 10 So I have already designed another mixed design for the self-compacting concrete using 20 aggregate. You can watch that one also if you want to watch. That is for the M30. The link is there or in the description. You will get the step-by-step process how to do a self-compacting mixed design for M30 using 20 aggregate. Today, the 10 The next is what is the exposure condition as per table 3 and table 5 of IS 456. Now, in IS 456, it's given what will be my exposure condition. Now, according to the IS 456, there are 5 exposure condition. That is my mild, severe, very severe, extreme, and harsh. So, whatever the condition of your concrete, that means where you are doing the concrete, according to that you need to choose what is the my condition. And in the table 5, it is given the recommendation that what will be the maximum water cement ratio and minimum cement content, and what is be the minimum grade of concrete according to the severe condition or according to the very severe condition or the extreme condition. So I have made a detailed video on that exposure condition according to the IS 456. If you want to know, the link is there or in the description. Please check. You will get full information about the exposure condition, which is explained within very briefly as per IS 456. So now we have find out as per 360, maybe you are getting severe and maximum water cement ratio will be 0.45. You can check that one, you can find out. Then what is the characteristics of self-compacting concrete? That we need to define what will be my characteristics or the properties for what we are designing. So first is some flow class, passing ability or the Elbach test class, V1L flow time test, on the Sieve aggregation, resegregation resistance. These 4 category we have to define in order to do the proper mix design. Say for example, here I'm doing the SF3. That means some flow will be 760 to 850 So according to that, there are 3 grade of self-compacting concrete: SF1, SF2, SF3. Say for example, here we are taking SF3. Then passing ability or the L box text, what will be the ratio of H2? Here we are considering that 0.9. Then V funnel, or that is a viscosity or time, that will be, we are considering that V1, that is less than 8 seconds. And the sieve segregation resistance, that is also less than 15%. Now, what is all this and why this is differentiated SR1, SR2, V1, V2? I have made a detailed video on the properties of the self-compacting concrete, where I describe each and everything about the sum flow, passing ability, V funnel, and the sieve segregation resistance. If you want to know, it is my recommendation. Please look on that or in the description, so that you will get full information that what are the different kinds of properties is there, and accordingly, as per your requirement, you need to choose that what kind of self-compacting concrete needs to be designed. Here we are considering this SF3 and this all. The next is, what is the degree of side control? Because it is very much important. According to that, the degree of quality control, that is a standard deviation, also will be changed, and the characteristic strength will be changed. So here it is saying that is good. Next is type of aggregate. The maximum size we said 10 mm. Now it is a crushed angular aggregate. There is a oval shape, there's a round shape, that different types of aggregate is there. But for the design purpose, here we are considering crushed angular aggregates. So all these things you need to fast finalize in order to do the mixed design. The next part is maximum cement content. This is also in the IS 456. It is mentioned what will be the maximum cement content, that is 450 kg per cubic meter. That cement content, not including fly ash and GGBS, should not exceed the 450 kg. So cement should not be more than 450 kg. So that is also given the guidelines that for more than 450 kg cement we cannot use. Why? Because whenever we are using cement, the heat of hydration is become more, and if the heat of hydration is more, that means heat is generating more, so that there can be a thermal crack in the concrete itself. To minimize that thermal crack or the heat of hydration, there should be a limit for the use of OPC, or the cement type. That is why the IS code has given that the maximum cement content can be 450 kg per cubic meter. The next is chemical admixture type. Now we are using chemical admixture in every concrete. Without the chemical admixture, it is impossible to do the mixed design as per our requirement. So here are two types of admixture can be used in SCC, that self compacting concrete, that is a super plasticizer, and the viscosity modifying agent, or the VMS. So it is playing that super plasticizer, it is retention time, and the water content become the less, but the viscosity modifying for the flowability, how viscous this mix should be, it is determined for the using of VMA or the viscosity modifying agent. These two type of admixture can be used, but here I am only giving you the example for the super plasticizer. If your viscosity is like more, then you have to add the viscosity modifying agent itself. Now, if you want to know about the different types of admixture, I have made a detailed video. It is my recommendation. Please watch that, or in the description you will get the full information about the different types of admixture. Now the next part is the mineral admixture. This is the chemical admixture. Now we want to use the mineral admixture. Here we are using pulverized fuel ash, conforming to IS 3812. Now why this mineral admixture to be used? There are two requirement. One is already discussed about the heat of hydration. Whenever we are using alone the cement, that maybe its cement content will be more, and then the heat of hydration will be more, as I discussed earlier. And whenever we are using this PFA or the pulverized fuel ash, what is happening? It is a byproduct. So whenever we are using byproduct, that means we are helping to protect the environment. Otherwise, this PFA or the fuel ash to be disposed on the earth, so the earth, the soil contaminations, water contamination, and the air pollution can be happen. So in order to reduce that one, we are using as a mineral admixture in our concrete, so that we can protect our environment. So here is the two benefits for using the pulverized fuel ash. One is for the environmental factor, another the heat of hydration. Next part is specific gravity of raw material. Why we want to know the specific gravity of raw material? Because in order to determine the volume, in order to determine the how much percentage or how much quantity, we need to know the specific gravity of the different material. So cement, here we are considering 3.15, fly ash 2.2, coarse aggregate 2.74, fine aggregate 2.65, and chemical admixture 1.08. Now, if you whenever you are doing your own mix design, please check at the laboratory that what is the specific gravity of the raw material, whatever you are using at the site or for the mix design purpose. It will give you the exact result or exact proportion. So it is my recommendation to do a test for the specific gravity also for the raw material. The next step is what is the water absorption. That is very much important to know the water absorption. So here we are considering the coarse aggregate is 0.5% and the fine aggregate is 1%. Why water absorption is none? There are different scenario can happen whenever we are adding water into the mix. So what is happen if the coarse aggregate or the fine aggregate is dry condition, it will absorb the water from the mix and there will be less water for the chemical reaction. Or in other way, if it is as the moist condition, then it will release the water in the mix, so there will be a more water into the mix. Either way or the both way, it is harmful for the concrete. We need to very precisely for the water condition. That is why you need to know whenever you are doing any concrete or any mix design, what is the water absorption capacity of the coarse aggregate and the fine aggregate. Here we are considering 0.5% and 1%. And the free surface moisture condition, we are here, it is considering nil. Why? We are doing the mix design in SSD condition. That means surface saturated dry condition. What does it mean? It means that neither it will release the water into the mix, nor it will absorb the water from the mix. So it is in the neutral condition. Now, what is SSD condition? That for that also I have made a detailed video, link there or in the description box. Please watch that one. You will get the full details about the SSD condition. For our mix design, I am considering that I am using all the aggregates in SSD condition, so the water correction should not be required here. The next part is my Sieve analysis. It is very much important to Sieve analysis because it has to satisfy the Indian standard or the IS criteria, which is described in IS 383. So whenever you are getting the coarse aggregate or the fine aggregate, you need to satisfy the criteria in table 7 of IS 383. So my case, I have to check the table 7 because I am using 10. So 10 here you can say 20, 20, 30. If it is a distribution, we need to know doing the Sieve analysis. Why we need to know the particle size of distribution? Because if it is not the well graded, so there may be possibility that there will be void whenever we are doing the concrete. And if the void is there inside the concrete, what will happen? This void will not gives the homogeneous mix or the hardened concrete. So we are not getting the that much of the strength or the durability because there is a air pocket. So that is why it is very much important to use the well graded mix. So what that is why in the IS 383 in table 7 for the coarse aggregate and uh, table 9 for the fine aggregate, the IS 383 is given the guidelines that they means whenever you are getting the coarse aggregate or the fine aggregate in your side before doing the mix design, you need to satisfy the particle size distribution or the Sieve analysis criteria according to the table 7 and table 9 for the coarse and the fine aggregate as mentioned in the IS 383. I hope that whenever you are doing this Sieve analysis, we are using here zone 2. So we are getting the zone 2 and for the 10 mm as per the requirement, we will find out. So after doing the Sieve analysis, now we need to finalize the next thing, that is what is my target strength. Now, why this target strength? Because I am doing the mix design for the M50. Now, why I need to do the target strength? Why you need to increase this here? So for that, you need to know what is a bell curve or the normal distribution curve. Whenever we are doing the mean, that mean from the negative side and the positive side, then it should be as per the requirement. So that is why code has given this formula, this FCK or the dot or the target strength of is FCK plus 1.65 S or FCK plus X, whichever is higher. So here is S is the standard deviation or X is the multiplication factor. It is given in the IS 456 as well as in the IS 10262. So for the design purpose, we need to know the what is my target strength. If we can achieve that target strength at the laboratory or in the design, it can be ensured that whenever we are doing the actual concrete at the site, we will get that strength or the for the 50 MPa or the 40 MPa, whatever my target strength. Now, it is also satisfying the bell curve or the normal distribution curve for the concrete strength. So here it is 1.65 S in the standard deviation, where we can getting already have given that this we can get it in the IS 456 on the one IS 210262. Here it is for my M50 is 5. So 5 plus 1.65 into 5 is equal to 50 plus 8.25, 58.25. And another factor is FCK plus X. X is how much? Here, see, you can see here for M50, 6.5. So 56.5, here it is 58.2. And what is code says, whichever is higher, that has to consider. So we need to do our mixed design or calculation for the 58.285 Newton per millimeter square in order to achieve the strength or achieve the M50 grade of concrete at the site. So now we finalize what is my target mean strength, that is 58.25. Now, what is the approximate air content? So it is depends on whatever the maximum size of aggregate we are using in the mix. Now, what is my maximum size of aggregate? That is 10 mm. So from this table also, we can find out in table 3 of IS 10262, that is for 10 mm, the entrapped air is 1.5%. So why it is required? Because it is very much important to understand what is my air content. Why this? For the calculation purpose. If it is not calculating, then maybe for we design for the 1.1 cubic meter concrete, but it will give not the 1 cubic meter volume of the concrete, will give the less, because we are not considering the air content inside the concrete, and it is depends on the maximum size of the aggregate. Here it is maximum aggregate 10, so it will be 1.5%. The next is selection of water cement ratio. From where we can getting that one? I hope all you people know that there is a curve given in the IS 10262 in IO 2009. In this curve, it is there are three curve 1, curve 2, curve 3. In this three curve, it is showing curve 1 is for OPC 43 degree, 33 degree, and curve 2 is OPC 43. And what we are using here? We are using here our concrete is OPC 53 grade. So if it not OPC, that other than concrete, in the case of whenever PSC and PUSC use for this, carb 2 may be assumed. So if we are using other than OPC, then carb 2 should be followed. For here it is a carb 3 and our concrete is 58.28. So here it is 58. It is coming around 0.32 or 0.31. Okay. So we are considering, we are getting an idea, that we are getting an idea from this, that the my maximum water cement ratio can be 0.3 or 0.31 like this. So it is giving the guidelines that how much will be the criteria. So here we are getting this 0.31 or 0.32, but we are considering 0.3 and it is less than 0.45. So 0.45 where we are getting table 5 of IS 456, it is saying that for the severe condition, because we are considering that it is the severe condition, that is why for the severe condition, the maximum water cement ratio is 0.45, and from the graph we are getting 0.3. That means it is given the clearance, or it is satisfying the criteria mentioned as per IS 456. Now we are getting this 0.3 is my water cement ratio. Now For now, we can find out the what is my water content. For SF3 class, let's start with water 170 kg per liter and admixture 0.6% of mass of cementitious material. Now, here already given in the clause 8.3 of ISO 10262 that water content to be between 150 to 210 kg per cubic meter. So IS code also given that guidelines also what will be my range of water content. So here we are considering 170 kg per liter, sorry, kg per cubic meter. It's not kg per liter. Let me kg per cubic meter and admixture 0.6% of mass of cementitious material. Total mass of cementitious material, whatever we are using, 0.6%. So now we have find out my water cement ratio. We have find out my water content. Now next is cement content. It's very easy. How to find out cement content? Here it is 170 is my water and 0.3 is my water cement ratio. So it is coming 170 by 0.3 is 567 kg cement to be used in the mix in order to get the required strength of 58.25 or M50 grade of concrete. Now, here it is violating the maximum cement content. Can you remember what is my maximum cement content? That is 450. So it is violating. So it is not as per the IS code. Then what we can say? Next part that this you can part replacement of cement by using the supplementary cementitious material GGBS or the fly ash. Here we are using the GGBS, that's the fly ash, that is pulverized fuel ash. So it is saying that it is generally 25 to 50% of fly ash we can use. Let's consider 25% because if we go more, then it is difficult to get the desired strength. So start with 25% and then fly ash content, how much? 25% of total cementitious material. It is coming 142 kgs. And then final cement quantity 567 minus 142, 425 kgs. Now it is satisfying the criteria as mentioned in the IS 456, less than of 450 kgs. Also another criteria in the table 5 also, that what will be the minimum cement criteria, that is 350 for the severe condition. That is also satisfying. So we have already satisfied each and every criteria is mentioned in the mixed design. So what do we have find out? We have find out water cement ratio, we have find out water content, and we have find out cement content and the supplementary cementitious material, that is fly ash content. The next is admixture content. So what will be the admixture? That is 567 into 0.6%, that is 3.4 kg per cubic meter. So now we find out my admixture content also. Then the powder content. Now it is very much important to understand that self-compacting concrete has the property that is it will flow with its own weight. So that is why powder content is a very much crucial factor for the self-compacting concrete or for the performance of the self-compacting concrete. In normal concrete, we are not thinking about the powder content, but for the self-compacting concrete, you need to finalize what is my powder content. For that, powder content means the ingredient in the mix finer than 0.125 mm. So in 0.125 mm or the less particle, whatever in the mix is available, that is to be considered as the powder content or the finer particle. So what will be there? That will be, it's given in the code that it should be 400 but 600 for, but it is in the lower grade it is possible, but we can go up to that also, that I will show later. Our mix is SR1 and beyond characteristic. Let's powder content 633 kg. Now this 633 kg, what is? That is cement plus fly ash or the pulverized fuel ash, and from the fine aggregate, whatever the percentage below the 0.125, that will be also contribute to the total powder content. Now, what is my total powder content we consider? That is 633 kgs. And around 10% of the zone 2 sand is belongs below to the 0.125. So what is my total content of fly ash and cement? That is 567, and I am considering total powder content 633. So 633 minus 566, that is 66 kg is balance for the powder content in the mix. From this 66 kg, from where it will come? it will come from the fine aggregate. So whenever we are doing sieve analysis, we need to find out how much percentage is going down the 0.125 mm. So that will be contributed to the total powder content of the mix. So this 66 kg should be come from the fine aggregate. Now we can find out the fine aggregate quantity. How? This 66% is coming at around 10%. Let's consider it's 8% is contributing this 66 kg. So total fine aggregate will be 66 by 0.08, that is 829 kg per cubic meters. It's clear that from the powder, total powder content, we are just subtracting total fly ash and cement quantity, then we are whatever we are getting, that is contributing maximum 8 to 10% of the fine aggregate. So here we are getting 66 kg. So 8% of total mass of fine aggregate is equal to 66 kg. So what will be the total mass of fine aggregate? 66 by 0.8, that is become the 829 kg. So now we also find out what is the my fine aggregate quantity. So what is cement quantity? This is fly ash quantity, water content, water cement ratio, powder content, and fine aggregate quantity we have already find out. Now we need to check the coarse aggregate. Now what is everything is clear. Now it's coarse aggregate. Now how we can determine the coarse aggregate quantity? That is, we need to check the coarse aggregate volume first, then it will convert it into the coarse aggregate in weight or in the kgs. So first, what will be the volume? 1 minus air content. So we are considering 1 cubic meter content concrete. So our total volume will be 1 cubic meter and minus air content. So what will be the air content? That is to be minus. If it is not minus, then the total volume will be the less. So what is my air content? I will come later. Then minus of volume of water, volume of cement, volume of fly ash, volume of file aggregate, and volume of admixture. So all other, if we are minus from this total volume, we will get the coarse aggregate volume. Now we know all this. What is air content? Air content, that is from 10 mm aggregate, it is maximum 1.5%. And for the volume of water, we know volume of cement, and I will find out. So volume 1 is my total volume of concrete minus 1.5%, that is 0.015, minus volume of water. How much? 170 by 1 into 1000. What is why 1000? Because it is in the specific, it is specific gravity, so it is minus 1000 divided by 1000. Then cement 425 minus 3.15 is my specific gravity into 1000. It will come into the cubic meter. Plus 142 is my fly ash weight. Then 2.2 is the specific gravity into 1000. It will give into the cubic meter. 829 by fine aggregate quantity. Then 2.65 is the specific gravity into 1000. And 3.4 is my admixture quantity by 1.08 into 1000 is my volume of the admixture. Now, 1 minus 0.0, 0.98985. Here is 0.170, 0.1349, 0.0643, 0.3128, 0.0031. It's coming 0.30 cubic meter. Now, I am getting the coarse aggregate volume in the mix, that is 0.03 cubic meter. Now, we need to convert it into the mass of coarse aggregate. How? This specific gravity is 2.75 divided by into 1000. So it is coming 824 kgs. Now I am getting the coarse aggregate volume or mass also. Now, so I get everything whatever need in my design. Now we need to check the volume of powder content, because we need to know the what is my powder or water to powder ratio. That is a very much important in the mixed design for the self-compacting concrete. So what is the volume of powder content? Again, you can remember the powder content means the total volume of cement, total volume of fly ash, and the finer particle available in the sand, that is which is lower than 0.125 millimeter. So 425 is my cement content divided by 315 is specific gravity into 1000. 142 is my fly ash content divided by 2.2000, and 66 my is the contribution from the fine aggregate is the finer particle. So here it is coming 0.2243 is my total powder content. Now the ratio to water to powder it is 0.17 is the volume. It is remembering that the water to powder ratio is always in the volume, not in the mass. So we need to convert all into the volume. So here it is coming 0.76. Although IS code is giving this 0.85 to 1.15, one between it should be 1.85 to 1 to 1. But for the higher grade, it is not possible to maintain that one. You can try, but you will not get the concrete as per your requirement. That is why it is giving some slight difference in from the IS, but from it is coming 0.76. So my ratio of water to powder is 0.76. Then fine aggregate percentage to total aggregate. That also IS code given that it should be in between 48 to 60%. That means it has given the guidelines to satisfy that what will be my fine aggregate to course the total aggregate ratio. See, my 829 is my fine aggregate, and 825 plus 24 plus 829 is my total aggregate. It is coming 50% of the total aggregate. So it is 50 or 57, 1 point something like this. So to be in between 48 to 60. So this is also satisfying the criteria mentioned in the IS code. Now, my first mix proportion or for the trial, that is cement is 425 kg, fine aggregate 829 kg, coarse aggregate 824 kgs, water 170 kgs, admixture 3.4 kgs, fly ash 142 kgs, water cement ratio 0.3, powder content 633, and water powder ratio is 0.76. So these things you need to do the trial. But remember, this is just a guidelines, or as per your project requirement, you need to do the self-compacting design very precisely and carefully, because it's a special type of concrete. So you need to give proper precaution and special care. So according to your requirement, you need to do the trial, and maybe you will achieve or may not you will be achieve. But always you can do the trial mix, trial 1, trial 2, trial 3, or whatever the result you are getting from trial, or it can be used in the trial 2. So these are the simple guidelines for the mixed design for the self-compacting concrete using 10 aggregate. And I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And I'm waiting for your comments so that what you want to know about the quality control and the construction. So I will come with more content like this. And thank you once again for watching me.